Hello, and welcome to the second episode of Total Dino, the podcast that asks, what's your favorite dinosaur? I'm Tim, and hopefully I have something a little more put together than the first episode for this one. If you listened to the first episode of this podcast, I apologize. It was sort of a mess. I was kind of all over the place, but I think that's pretty forgivable, because it was only the first episode. I'm still trying to figure out the format and structure of this, and I'm still getting feedback on what you listeners want to hear. But I've got some stuff planned here. I've got some news, and by news I really mean it's just a paper that just came out, which is very dinosaur relevant. It's pretty cool. And then I've got a little lesson about what makes a dinosaur, which I think you guys would appreciate. And then I've got some fan interaction stuff that you guys sent me, which is really fun and really cool. So let's just go ahead and dive into it. Starting with the news. Again, by news, it's just a paper. It's not a news article. This is a scientific paper that just came out in the past week. Or so, depending on when you're listening to this, of course. This paper is entitled Observations on the Skull of the Type Specimen of Tyrannosaurus rex, Osborn, 1905. It was written by Thomas Carr. So, let me go ahead and explain a little bit. T-Rex, you may have heard of. T-Rex is short for Tyrannosaurus rex. It is probably the most famous dinosaur. You've probably heard of it. The word holotype is the other thing I need to explain. A holotype is the individual specimen of a given species, animal, plant, or whatever, that other individuals are compared against. If scientists say this individual is this species, then every other one they find has to be compared to that to say that's the same or it's not. In the context of dinosaurs, that's pretty much always fossil remains of the bones and the skeleton that's discovered, and it's usually the first one of a species discovered. So, for example, when they found the first T-Rex, they said they named it Tyrannosaurus rex. This individual is Tyrannosaurus rex, and then every T-Rex or every dinosaur they found since then, if they thought it was a T-Rex, would have to be compared to that individual, and they would say, yep, this is also a T-Rex because it's the same as that one, or no, this one has a little bump here, or too many teeth, or the snout is too narrow, or whatever. And it's not just T-Rex, this is all dinosaurs and all new animals and everything that's discovered, so they have to pick one to be the example, so that when they find other ones, they can say, well, this is the same, or it's not. So, the first Tyrannosaurus rex fossil was discovered in 1902 by Barnum Brown, and it was described by Henry Fairfield Osborn in 1905. This is over 100 years ago, obviously, and scientific measurements and techniques have updated quite a bit since then. So the T-Rex was discovered like I said, discovered in 1902, described in 1905, and it's kind of just been sitting around. Well, that's not completely true. So this fossil's name, or the code for it, is CM9380. CM is the Carnegie Museum, so I believe it's currently mounted in that museum right now. But as far as scientific analysis goes, it basically hasn't been measured or really formally described in over 100 years. Kind of interesting note, before that, the carnivorous theropods that they were aware of was basically the Megalosaurus. That was actually the first dinosaur described by science. So, which is from the Jurassic, and it's a carnosaur. I think the much more popular and numerous theropods ended up being Coelurosaurs, which includes the T-Rex. So it's kind of funny that they had a Jurassic Carnosaur, and that's kind of what they thought of as this is what theropods look like, until they found the T-Rex, of course. I mean, I'm sure they found a lot of other theropods in between that time, but, you know, it was a big deal. So anyway, it's been sitting around, not really described by modern techniques until this paper. So Thomas Carr measured the T-Rex skull using detailed physical measurements, photos, and comparisons across other specimens, notably juvenile specimens and other questionable individuals that may or may not be T-Rex, taking measurements and basically describing like this is the holotype, so this is what has to be the definition of a T-Rex. Anything that's too different from this is not a T-Rex. So it's going to inform a lot more future descriptions on other tyrannosaurs and animals that are similar enough but might not actually be T-Rex. It'll be in the same family but maybe a different species or a different genus. The paper is mostly just a bunch of data and measurements, the length between this bump and this tooth and this snout. So it's not exciting to actually sit down and read, like most scientific papers. But that's basically it's been formally described using modern techniques, and that's really exciting. So a lot of good new data on the Tyrannosaurus Rex holotype. So that's the paper. It's by Thomas Carr. It's really interesting, so check it out. And of course, I got to jump in and say, let me know in the comments and all that if you found that interesting or if you found it kind of boring. Do you want me to do more exciting news stuff? I think this is exciting, but it really is just a bunch of data. So let me know in the comments on YouTube or on the podcast, wherever you find this. Let me know. Anyway, so let's jump on into the main topic here. I want to talk about what makes a dinosaur a dinosaur. I think this is an appropriate topic for the second episode, because if we're going to get into dinosaurs and keep going with this, pretty early on, you kind of have to set up what you're even talking about. So, dinosaurs are a group of animals. I'm not sure if that really needs to be explained, but sometimes it seems like it does. It's not just an abstract concept of large, extinct, scaly monster animals, or just because it's big and dead doesn't make it a dinosaur. It is actually a phylogenetic clade. Phylogeny is the study of how animals are related based on their evolutionary relationships. I actually have a YouTube video explaining this, so check that out. It's youtube.com/@TotalDino. I think that's how YouTube URLs work. /@TotalDino. It's called Dinosaur Phylogeny, something like that. That's going to be all the info I'm about to say, but much more scripted. So check out that YouTube video, or just here we go. So phylogenetics is the study of how how organisms, animals, plants, fungi, everything is related based on their evolutionary relationships and categorizing them with that. There's sort of an old-fashioned system. You've probably heard of the phylum, kingdom, phylum, class, order, family, genus, species. They still kind of use these words, but it's a lot messier. It turns out that evolution is a lot messier than it was when they came up with that. So I really just like to call them clades because it makes it feel like everything's in some organized level, and it's really just not that organized. So if you've heard of a class of species or a family, it's the same thing, but just the word clade is just kind of the general term for that. So the way a clade is defined is, well, basically, as animals evolve through time, a species will, if two populations of a species get separated, like by a mountain range, or if some population ends up on an island somehow and they interbreed isolated from each other, so there's two populations not mixing with each other, over time, eventually they'll evolve as they adapt to their environments, and just through random mutation, genetic drift, they will eventually become different species if they never meet and interbreed. And over time, that gets more exaggerated and they become more distinct from each other. And then from there, each species could differentiate and speciate, it's called speciating, by splitting its populations again by for whatever reason. Maybe they move to a different island or a different mountain range pops up and gets in the way. This takes millions of years, so, geological formations get in the way a lot. I mean, there's all kinds of stuff that can cause this. But anyway, the point is, one original species can have descendants that split into other species, and each of those splits into more species, but a clade is defined by all the animals, all the different species now, that have descended from that original one. So you'd kind of define it as the common ancestor. The common ancestor is the one ancestor that they all have in common. So you'd say the common ancestor between this species and this species, and you'd go back however many millions of years, and say this was the common ancestor. Everything descended from this species is a blank, a dinosaur, or a mammal, or a canine, or whatever. So, like I said, all animals and plants and all life is kind of defined and categorized by this. And this is where you see those diagrams that look like a family tree of branching lines. That's called a cladogram, because it's a diagram of the clades. It all makes sense. And you can look back and say, like, dogs and wolves are both a kind of canine. Canines are a type of mammal. Mammals are a type of vertebrate. So it's all categories that fit within each other, going backwards along the cladogram. And you can categorize them by what their common ancestor is. So, dinosaurs are not an abstract idea of just big extinct animals. They are defined by their common ancestor, which was a reptile from the Triassic, probably the late Triassic, maybe the middle Triassic. We don't actually know this species from the fossil record. It doesn't have a name. It's kind of a theoretical thing, but it is a real animal that really existed. We just haven't found it. We know how evolution works, and we know that a common ancestor must exist. We haven't found it, But we know that dinosaurs really kind of appeared in the late Triassic. They're kind of defined by, so that's the phylogenetic definition. They're also defined by their what's called synapomorphies. These are physical similarities between animals. It's kind of how you can tell just by looking at them physically that they are related. I briefly mentioned in the previous episode the sacral vertebrae. These are the backbones, the vertebrae around the hips. Sacrum kind of means the hips. Dinosaurs all have at least 3 fused sacral vertebrae. That means they're kind of attached. As the animal grew, they fused together. And you can see this across all dinosaurs, and that's one thing that kind of defines them. Some other synapomorphies are they have an open hip socket. The way their hips are set up, there's a hole that goes straight through. You can see through it if their legs aren't there. Also, the way their hips and legs are set up, they stand up vertically with their legs directly under their bodies, which is a really big, important defining thing about dinosaurs. It makes them more not agile. I don't want to call sauropods agile, but more efficient in locomotion. You see this in theropods, sauropods. They all, at least ancestrally, have vertical pillar-like legs, as opposed to, say, like crocodiles and lizards whose legs sprawl out to the side. So these are reptiles. Dinosaurs are related to crocodiles and more distantly lizards, but their common ancestor is evolved after it split off from the crocodilians. So yeah. So anyway, these are synapomorphies. This is how you can kind of look and say these are related, and then you can look in a fossil record and you can kind of see how they evolved. So the phylogenetic tree, the cladogram, if you're picturing like a tree, family tree kind of thing, if you go back far enough, like I said, all living things have a common ancestor. The mammals and reptiles, if you go back far enough, have a single species that we both split off from, called the amniotes. And then if you go down, if you don't go down the mammal side, if you go down the reptile side, that splits off into I think turtles. Actually, turtles are weird. We don't know where turtles are. And then the squamates, which is lizards and mosasaurs, and then that splits off from the archosaurs. So archosaurs are the group that contains the common ancestor that gave rise to the crocodiles, the pterosaurs, and the dinosaurs. So if you can kind of picture this, a visual aid is very helpful for this. Again, check out my YouTube video. But archosaurs are defined as the all descendants of the common ancestor between dinosaurs and crocodiles, or the crocodilian group. And what that means is if you go up, look backwards up the dinosaur lineage, and then go up the crocodilian lineage, you find eventually the common ancestor, which was a long time ago. And then if you go down from that, you'll see the crocodilian line, and then after the crocodilian line splits off, there is the pterosaurs, and the pterosaurs and dinosaurs split apart. So the pterosaurs, if you don't know, are the flying reptiles, the flying archosaurs that, Pteranodon and Quetzalcoatlus and Rhamphorhynchus and all those. Very interesting group of animals, but since their ancestral common ancestor split off apart from the dinosaurs, they are, by phylogenetic definition, not dinosaurs. And then you have this little bipedal carnivorous reptile that was the original dinosaur. And everything that evolved and descended from this animal, by definition, is a dinosaur. So what that means is, since pterosaurs split off before this original common ancestor, and farther up, the crocodilians split off before that, this group is the archosaurs, but by definition, pterosaurs and crocodilians aren't dinosaurs. A lot of times people seem to think that crocodiles are like living dinosaurs. They're closely related, but they are not dinosaurs because they are not descended from this original, the defining ancestor of the dinosaur group. And also, like mosasaurs, not dinosaurs because they branched off earlier. Pterosaurs are the closest major group that we know of that's closely related to dinosaurs, but still not dinosaurs. So then, you've got the original dinosaur. Now, I don't feel like I need to explain speciation every time. You get it. So it's easier to talk in terms of like a family tree. So picture one group splitting off and then splitting off like a family tree cladogram. So the dinosaurs, the original dinosaur lineage, early on split off into two groups called the Saurischia and the Ornithischia. The synapomorphies for these are mainly the hips. Ischia means hip, so Ornithischia means bird hip, ornith means bird, Saurischia meaning lizard hip, saur meaning lizard. So, ironically, the group that contains birds is within the lizard-hipped group, the Saurischians. That's just kind of a naming issue. When they first named these groups, they thought that the Ornithischians, the hips looked more like a bird, which like bird hips, which is it kind of does, but it's sort of just the weirdness of evolution and the way language sticks. But so we're stuck with that anyway. So the Saurischians then split into two further groups called the sauropods, or the sauropodomorphs. Before the true sauropods, there's sauropodomorphs, and then the other group in the Saurischians is the theropods. So when we're talking about dinosaurs, usually people think of it in three main groups: sauropods, theropods, and ornithischians. It's important to keep in mind that sauropods and theropods are more closely related to each other than ornithischians. That is, their common ancestor is more recent than the common ancestor between them and the ornithischians, which is the original dinosaur. There is a little bit of debate in some papers coming out saying that I think sauropods are closer to ornithischians. But I don't think that's got a lot of... It had some traction for a while, but I kind of think that's a little basically dismissed by now. So anyway, you got dinosaurs, split into ornithischians and saurischians. Saurischians are split into sauropods and theropods. And so these three groups I'm going to talk about real quick, and that's about as deep as I'm going to go here. So sauropods, which started out the more basal, or the earlier versions were called sauropodomorphs, or you might have heard the phrase prosauropods. So basically, these are the big, huge, long-necked herbivores. They were bipedal as they evolved in the Triassic and early Jurassic, but they pretty soon became so heavy they had to be quadrupedal. And they have long necks, and they are herbivores. And within this group, it branched off into a lot of different other groups, like the mamenchisaurs, diplodocus, and of course the titanosaurs, which were very numerous, a very huge group. And of course, keep in mind, these are all still sauropods, and sauropods are still saurischians. You never evolve out of a clade. So titanosaurs are sauropods, of course. And then the other saurischians are the theropods. These are the bipedal carnivores, mostly. There's a few herbivores that evolved. They're kind of the weirdos of the group. As I said earlier, the original common ancestor was a small bipedal carnivore, probably a carnivore. As dinosaurs evolved, they filled separate niches. Theropods are the only ones that stayed carnivorous. Sauropods and ornithischians evolved to be herbivorous. So theropods obviously are the T-Rex and the Allosaurus and the Velociraptors, basically any meat-eating dinosaur, and they are all bipedal. As far as we know, there have not been any quadrupedal theropods. If you're thinking about Spinosaurus, that is under some debate. Some people think that Spinosaurus kind of walked on all fours like a crocodile, but that is a discussion for another episode. And of course, there's some weirdos like Dinochirus, Therizinosaurus. These are herbivorous theropods. So they're the weirdos, but basically, bipedal carnivores, these are the theropods. And again, they are they're the sister group to the sauropods, which are saurischians. Ornithischians are kind of the everything else group, and it's not in a way that it's like a wastebasket group that scientists just throw them there because they don't go anywhere else. It's a phylogenetic evolutionary grouping. This is how they evolved. So sauropods are long necks, theropods are meat eaters, and ornithischians are everything else. This includes the ceratopsians, the stegosaurs, ankylosaurs, the hadrosaurs are a huge group. If you're listening to this podcast, I assume you generally know what these things are. The ceratopsians are like the triceratops with the horns on their heads. Stegosaurus has the plates and spikes down its back. Hadrosaurs are like the duckbills, some of them have crests. And these are all herbivorous, and they all have beaks, which is an interesting thing. Some theropods have beaks. Obviously, birds are theropods, so they have beaks, but all ornithischians have beaks. That is another common trait amongst all of them. So that is kind of the main groups. Obviously, I'll go into another episode getting more into each group within those, but within the sauropods, theropods, and ornithischians, these branch off, and they obviously speciated through the Mesozoic, and there's tons of groups within them and tons of different species. And again, these are all descended from one species in the Triassic, and they are called dinosaurs. So that is sort of the explanation about that. I do want to talk about a little bit of human history. I usually like to stick to dinosaurs, but it's kind of relevant here how humans came to this, how we talk about it. So in the mid-1800s, there were these big, weird bones that were being found. These all throughout human history, obviously, they found stuff that they didn't know what it was. But in the mid-1800s, European scientists were kind of saying, like, what is this? So this one guy, this one scientist in the mid-1800s, his name was Sir Richard Owen. He he looked at these ancient fossils and kind of realized that they looked like they were related. Obviously, they didn't know much what they were, but he could see that they were kind of large reptiles, and so he could see that they were kind of related, and he decided to, formally, scientifically group them and say these three animals are a related group of animals, and he came up with the word dinosaur. So Richard Owen coined the term Dinosauria. That's what the clade is now called. We call them dinosaurs kind of informally, but the official scientific name is the Dinosauria. That's their phylogenetic clade. Dinosaur, earlier, like I said, saur means lizard. Dino means terrible, so dinosaur means terrible lizard. He didn't mean terrible like they're monsters, like not in a bad way, but kind of more like awe-inspiring. It's a sort of loose Greek translation. Sort of side note here, actually. When I was making my little paleo art infographics, I have one section that has the translation of the dinosaur's name. For example, Stegosaurus. Stego means roof, and saurus means lizard, so roof lizard. They're not lizards, as we mentioned earlier. I kind of wanted to make it more scientifically accurate and translate saur as reptile. Sometimes you see like Stegosaurus would be roof reptile instead of roof lizard. But I looked into it, and it is the Greek definition of the word lizard specifically. So the Greeks, the ancient Greeks, I'm going off on a tangent here, they didn't really classify animals in the same way. So they didn't really have a word for reptile. Like there weren't clades and groups like this. But saur or sauria literally meant like the four-legged reptile, like lizard specifically. They had a separate word for snakes and a separate word for crocodiles. So calling them lizards, like Stegosaurus being roof lizard or the dinosaurs being terrible lizard, phylogenetically they are not lizards, but I decided to stick with the actual translation because that's what I'm going for, is the translated word, and I had to go with lizard because that's what the word means. So sometimes you'll see it translated as reptile because people are trying to be more scientifically accurate, but I, in this case, decided to be more linguistically accurate. So anyway, Richard Owen named the dinosaurs terrible lizards, and that's what we call them now, the dinosaurs, and that's what their scientific phylogenetic clade is, the Dinosauria, sister to the Pterosauria, and they are all within the Archosauria. And so Richard Owen just looked at them and said, these animals look similar. I'm going to group them in a group called Dinosauria. And as science progressed, phylogenetically we had to say, well, these animals must have some common ancestor, so we're going to make a phylogenetic group, we have to see how they evolved and how they're related. It turns out, I don't think I mentioned, these three dinosaurs are the Megalosaurus, Iguanodon, and Hylaeosaurus. So, in order to find how they're related, or, as science advanced, we had to see how they're related. It turns out that Iguanodon, which is an ornithischian, and Hylaeosaurus is an ankylosaur, specifically a nodosaur. We'll get into that in another episode. So Hylaeosaurus is related to Ankylosaurus, the armored ones. So Iguanodon and Hylaeosaurus are both ornithischians, and so if he defined the group by just those two, the name dinosaur would only go as far back as to include ornithischians. Since he included Megalosaurus, as I mentioned at the very beginning of this episode with the T-Rex paper, this was the earliest theropod, and so it turns out that in order to group them all together, you have to find the common ancestor between the ornithischians to include Iguanodon and Hylaeosaurus. You got ornithischians, but then to include Megalosaurus, you have to go all the way back to what is now obviously the original ancestral dinosaur, and then everything descended from it. So sauropods actually were kind of included later, but they sauropods just happen to be dinosaurs only because they are more closely related to theropods than to ornithischians. So it's in some ways a deliberate decision, but in some ways it's just, well, this is the named group and this is how they fit in. If Richard Owen happened to be looking at Pteranodon and he said the common ancestor between Megalosaurus and Pteranodon, then that phylogenetic group would end up being what we would call dinosaurs, and it would, be the common ancestor of the pterosaurs and what we call dinosaurs. And then so hopefully you can picture a cladogram of what I'm describing. It's all names made up by humans. The animals evolved, and they were just animals living their normal lives. They don't care what we call them. These are human constructs that we like to use these to categorize them and talk about how they're related. So so Richard Owen named them based on their synapomorphies. He noticed physical similarities in the fossils, and then we applied phylogenetics to it, and that's how we came up with the clade Dinosauria, and then everything that descended from it, and these are what the dinosaurs are. So hopefully that all wasn't too confusing. And so there you go. Now we can move forward, and in later episodes I'll get into more specific groups and how they're related and all that. And again, check out my YouTube video. It's a lot more succinct and scripted, and it has visuals. Total Dino on YouTube, Dinosaur Phylogeny. So check it out. And again, of course, let me know if this was too long or boring or confusing, and I will shorten it for future episodes. I will be reading the comments. So, speaking of comments and you guys' feedback, I did get some emails and some voice clips in response to my first episode. If you listen to that, I called out that you can send me some voice clips talking about your favorite dinosaur. So I got one from a fan online named Heather. She sent in this voice clip about her favorite dinosaur, Langosaurus. So let's just go ahead and let her take it away.
Longosaurus means longo lizard after where it was discovered in China. It was described by Yu, Ji, and Li in 2005. It is my all-time favorite dinosaur because it is featured in my all-time favorite anime, Dinosaur King. It is also known to have really large teeth, measuring at about 14 centimeters. This indicates that it had the largest known teeth of any known dinosaur.
Thanks, Heather, for sending that in. I'm going to go ahead and add just a little bit. So Langosaurus was an iguanodontian ornithopod, so it was pretty closely related to the iguanodon, which I mentioned earlier as one of the original 3 named dinosaurs. So it was about 10 meters long, and it looked like an iguanodon. It had a beak, it was a big herbivore, and as Heather said, it had the biggest teeth of any known dinosaur. So that's pretty cool. Thanks again, Heather. So if you want to get featured like Heather did just now, you can go ahead and go to speakpipe.com/totaldino. It's a pretty simple website. It'll just prompt you to record. You just talk about your favorite dinosaur and hit submit, and I will get it. So just tell me about your favorite dinosaur, why you like it. Talk as long as you want, and I'll put you up on the next episode of the podcast. So since my first episode, I also got an email from Jessica, who's an aspiring paleo author / artist. She was asking about my process, which is quite a discussion I can probably get into in another episode if there's enough interest out there. Basically, I use a program that's similar to Photoshop, and I do all the different parts, the head, the arms, the legs, in different layers, and I put the texture, whether it's scales or feathers, over it, and add shading and do separate textures and shading to each part. It's a whole thing. I also have a couple episodes showing my process on YouTube if you want to go check that out. They're about 2 minutes long each. They're obviously sped up, so it's like a time lapse. The actual process takes me a good, 5, 6, 7, 8 hours, depending on how complex the dinosaur is. But if you want to see a sped up version, check it out on my YouTube there. In Jessica's email, she also mentioned that her favorite dinosaur is Apatosaurus because it was her first dinosaur stuffed toy, and of course because of Littlefoot from The Land Before Time, which is a movie that has a special place in my heart as well. So thanks, Jessica, and anyone else who wants to send me any emails or questions or anything like that, reach out to me at, you can email me at tim@totaldino.com, or, just comment or anything anywhere else. I'm pretty easy to find on the internet. You go to totaldino.com and there's a contact form, which also just goes to my email, so... and if you want to request specific featured dinosaurs that will be popping up on my social media, or request topics for the podcast or YouTube, definitely check out patreon.com/totaldino. The more support I get there, the more I will be able to make more podcasts and content, because I have to juggle my real life with it, and Patreon definitely helps. So let me know what you think of all this in the YouTube comments and on TikTok and on the podcast hosting sites, wherever you find this. I will read the comments. And speaking of YouTube, I actually had one commenter from the last episode say that if I get somebody to talk to on the podcast, it would improve the quality because it would be more conversational. I'd have someone to go back and forth with. And I agree with that, but unfortunately that would require me to have friends that would like to talk to me about that. So I'm just alone for now. Maybe in the future I'll get some guests or do some kind of interviews or something. I don't disagree. I would like to have someone else to talk to, but it is what it is. So so here I am. And speaking of talking to other people, you can go ahead and come talk to me on Discord. That's right, I have a Discord channel, server, whatever it's called. Check it out at totaldino.com/Discord. That will just redirect you right into there. So, I've rambled on about this enough. Yes, I am on social media. I have Patreon. Do all the things. Talk to me. Tell me your favorite dinosaur. I feel like I'm getting a structure down. This podcast definitely felt a lot better than the last episode. Thank you for bearing with me, and let me know what you guys think. Send in requests, tell me your favorite dinosaurs. This has been the second episode of Total Dino, the podcast that asks, what's your favorite dinosaur? Bye-bye.